Hello everyone, this is my code for the game I made for the project for CS 110, and I made a game called Texas Hold'em, and it has basically the same outlook as the game, but it has a few variations that I implemented just for fun. So first, I'm making a deck. The deck will have the way I'm doing it. I have 4 lists: spades, diamonds, hearts, and clubs. And what I'm doing is I'm iterating through this list, and as you can see, I'm using strings. I iterate through this string and through this list of strings, and I append each one of them to these lists. But I would add a new substance to them, and that would be the character for this Unicode. And these Unicode stand for the characters for a spade, diamonds, hearts, and clubs. And that's what I'm basically doing. And after that, I will put all these in one list, and then I will be going around for the range in this list for the length of this list, and I would try to get the index of it, and the index would be what I'm as a parameter will be given as a parameter to this function. And when it gets that parameter, and that parameter equals the index of some number, as you can see, that's what I'm doing over here. That the index of that number put back in that function, L of I would be returned, and L of I would be one of these lists. So in the next function, I have it's basically an application of this one, and I'm making a new list, and for I in range number would be how many times I'm running this loop, and I would be going random deck equals deck rand int 0 to 3. So I'm basically randomly generating a number from 0 to 3 to put in deck, and that would be the index that I will be looking for. And 3 will transfer to clubs, and 0 will be spades. Anything between will be diamonds and hearts. So, and then from this deck, I'm finding a random card basically. And that would be going from 0 to 12, because this list goes from 0 to 12. And then I'm appending that random card into this list, and I'm returning this list then. And someone should notice by now that this is not implementing any decrease in the size of the deck when a random card is taken out of it. So this doesn't implement it at all, and I did that for a purpose. And I could have easily implemented a way to transfer to make sure the random deck decreases as a random integer is taken out of it. And I'll be using the pop method for that, but I'm not doing that because I don't know. I find this to be more interesting when you have when we have 2 or 10 players having the same cards, and all of them expecting to win. Probably have like all aces, and they expect to win, but at the end, everybody wins. And I found that to be a very hilarious part of the game, and I kept this code because of that reason. Next, I have this Boolean that will be checking if person folded or not. And basically, how we'll be doing it is the player will be inputting BF, capital B, or capital F, and if it's not one of those, the player will be asked to try again, and it will be putting in what he has to be putting in, and try again will be true, and this try again would be for this loop function, and this while loop function, and when this try again is true, the condition of this will be true, and it will be run again. And then after that, if it is in one of these, it will be the try again will be false, so I don't want this to run again. Return checker be lower, or checker B, basically the smaller version of B and the bigger version of the capital version of B. If it's one of these, it will turn true, and if it's not one of these, it will return false. And what I'm doing basically is, if someone betted, which B stands for, it will be returning true. And if a person betted false, betted F, which means fold, it will be returning false. So then, so that's how I'm working out with this function. The next function is basically a betting function, and it will be taken in as a pocket. This is what SumIQ is standing for. It will be taking a pocket, and what it will be doing is we'll be running this while function, and what this while function will be doing is checking if the bet is valid. Basically, that's all it will be doing. And because what I'm doing is I ask the player for a bet, and if the bet is less than 0, which would be done, which a player would be putting in that in to increase their pocket, so we can't have that. So I'm basically putting you bet less than 0, try again, and bet will equal betting of SumIQ. SumIQ would be this function over here, and I'm basically running this function inside itself, and then I'll be breaking it. And I could have done it without this, but then I tried it once, and when it worked, I was like, oh, that's so cool, I'll keep it in here just for fun, and that's why I have it in here. And then the next one will check if take notice that I'm using both if functions because I want both of them checked. If the SumIQ, the pocket minus the bet, is less than 0, that would mean that the player betted higher than what they had, and you can't do that. So I'm putting not enough money to bet that much, and I'm running that. I'm running the function again inside the function, and I'm breaking it. And what this break will do is basically it will run this function inside of it, and then if a player makes the same mistake again, it will be. It's actually like a little loop again inside a loop, basically inside the function, inside the function, inside the function. It will be if a player makes a mistake, it will be running this again. Or whatever mistake he made, it will be running that again. It will be running the function again, and if a person makes a mistake again, it will be running the function again. I find that to be very funny. So, and then try again would be false if it has went through all this without any problems, and because if they did any problems, they would be stuck in these little holes, I call them. And then if and then the exception for this try would be if a player puts in an invalid bet, which would mean they made a mistake. They put B, put some other character that's not a number, and then if that's true, if this doesn't work, I'll check this by comparing it to 0 and comparing it by minusing it to a number, and that's how I will know that the player put in something that's not a number. And then it will be printing input numbers please, and then it will be try again will be true, and this while loop will be run again basically, and then I'll be returning bet. Next I have these 3 functions. What they basically do is they control how things will work. So this hand would be standing for how many cards each player will be getting, which would be 1, 0, and what it's doing is basically running permutations 2 times, and this will be having will be a list with 2 with a length of 2, and that hand will be printed, and then it will be returned. And then round 1 is basically the same thing, but this I'm using this for the community hand. Well, I'm using this for each player's hand, which will be having 2 because each player will be having 2 cards in their hand, and the community hand first it will be running 3 because the first time it will have 3 hands, 3 cards in the community hand, which will be the flop, and then it will be printing the community card is this, and it will be after it's running this, this hand will be initiated because it's just 1, and hand will be plus equals permutations 3, and the hand will be returned. And then after that, round other would be any round other than that, other than round 1 or round 0. That's how I wanted to put it. And this would be after the flop, where the community hand it has 3 community cards, and that community hand would be added to itself, and it would be added one card as each for each time. This is one, and I'm adding one to it, and then I'll be printing it out how much now is current length, current characters inside, and that would be the hand will be returned as well. So that's what I'm having in this core function. The next function is logic, and logic is basically how I'm keeping everything together, basically. So first, I'm making a new list because I didn't want it to when I was doing this to damage the first list. Of course, I could use it with just the list, but if anything goes wrong, this would make sure that my list is not hurt at all. Because if you change something in the list in another function, it will actually affect the list, and that's because Python passes by values, I believe. Passes stuff by values. So basically, number holder, I'm making two lists, number holder and type holder. And type holder, I'm using it to hold the characters that list had. And this list is actually the complete case, which would be having 5 characters basically, and five values in that list, and then this would be wanting for J in new list, which would be each card, and if one of these are inside there, it will be replaced by just empty space and nothing really. They just this transfers to nothing in Python, and for type holder is appended one of these, and that's how I'm having this, because I only have one possibility for all these. They are mutually exclusive, so that's why I'm using if, else if, and else. And then what I'm basically doing over here is I'm giving J, Q, and K a value of 11, 12, and 13, and if K is in number holder, it will be replaced as many times as it's in that. It will be removed in that list as many times as it is in that list, and J will be inserted, with J being the value of that key, and the key would be K, basically. I could have added I, but however I wanted it. It was however I wanted it. So basically, what I'm doing this is because I can't compute with J, Q, and K. Those don't give me values that I can play around with. Because 11 I could eval it and I can play around with it. But J, if I eval it, I'll just have a variable basically, and Python will be returning errors and lines of errors that I don't want to deal with. So, but that's why I'm basically replacing it by this in this function basically, and also I'm replacing 1 by 14 for another list. That's what I'm doing over here. I'm making a new list using that number holder, and I make a new list, number holder 2, and for K and number holder, if one is in K, basically what this is saying, 1 is removed and 14 is appended. And someone could notice that I'm not really caring about how I'm doing this, how I'm putting these inside the list, because I'm not worrying about no index, nothing, because I'm just appending at the end. And this is because I don't care about it, because what I'll be doing, I'll be showing you in logic straights. What I'll be doing is I'll be sorting the list, so I'll have them listed as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in that order, and you can see over here that's what I'm basically doing. And to finish this off, I will be returning all 3 type holder, number, and number holder, and basically in every list, every function I'm going to have down here, I'm going to be using this. That's why I made a new a helper function out of it. So on logic straights, I have a placeholder, number holder, and number holder 2 equals list important being this function, FL, which will be what I'm putting in here, and I have a comparer, which is just a big giant string, and I'm using this because it's much easier to compare the membership of something in a list into a string than it is into a list. And because I tried that with the list, and the way I was doing it, because I had multiple, I wanted to check the whole string, whole list in a list, check if that whole list is in another list, and I couldn't do that because how the checking into a list, the membership will be going is, it makes sense, of course. It will be checking if it's in one index, basically. So if I have 4, 5, 6, 7, 8, 9, 10, it will be checking if that is in one index. So I could have done this with a list, but it will be much more annoying to do so. That's why I'm using this. I'm converting it to a string. So I have straight string equal to 0, which would be which would be very important because I mean, if you have a straight composed of all basically royal straight, well, you have basically if you have a royal flush, you have that's much stronger than if you had a straight made out of 1, 2, 3, 4, and 5, basically, and that's what this will be checking. And that's where this the fact that I made them 11, 12, and 13, and that's how the game actually has them, because that's how you'd be counting them in most games. And so because I had them in this way, I could actually eval them and I could play around with them. So over here I have number holder, and I'm sorting it with key of integer, and it will be I'm basically changing it. This would be changing it. I wanna say that this would be having it in a string. Every character in that list would be a string, and I'll be sorting it, and with key integer I'll be changing it to basically an integer. And because what I'm doing basically here is I'm changing it to an integer, and each value is an integer, and I'm comparing those, and I'm sorting them in that as if they were integers, but they're still strings, because they will have at the end they will still have string quotes. The quote what you call the quotes over them, but how I would be comparing them would be in their values and the values they have as integers, basically. So over here I have string equals string 2 equals this empty string, and then this will be empty string equals empty string, and basically I'm running j in number holder 2, and the string will be added to +1 j, and since I've sorted them, they will be in this pattern, basically, and the string 2 will have each of the values that a number holder has. And basically what I'm doing is, if string 2 in compare for I in number holder, I'll be running this. That's how I'll be running this. If string 2 is in comparer, and that would be if it's right here or something, and straight string will be plus equal integer of I would be each the eval, basically, of that string. And I'm not using eval because I don't need to, because all these are integers. So if I had decimals, I would be using eval, or maybe float, but since they're integers, I chose to use integers. The def logic flush L would be basically having taking in the list important. Will be whatever list important returns, which would be all these 3 things. And logic flush would be comparing if it's a flush, basically. And the way you have a flush is if every one of those things in one list are the same. The type is the same. What I mean is all of them are spare, all of them are diamonds, or all of them are hearts, or all of them are clubs or something like that. So that's what I'm basically doing over here, and it would be counting how many times the character is in there, and since the list, like I said, has 5 elements. If one of these numbers is equal to 5, it would be returning true, and if it's not equal to 5, it would be returning false, basically. And take notice that I don't care which one of these characters, which one of these, if it's all clubs. What I'm saying is, if it's all clubs, all diamonds, I don't care about that. What I care is if all of them are clubs or all of them are diamonds, basically. So that's what I'm doing over here. And in logic pairs, what I'm basically doing is checking if we have pairs in one list. And I'm only using, as you can notice, that I'm only using number holder 2 for all of this, and that's because number holder 1 will actually be holding the same thing as number holder 2, but has 1 replaced as 14. And I'm using 14 a lot more than 1 because that's basically how you be using it, basically, because that's how it would be used, especially over here, because we don't care if it's number holder 1 or number holder 2. So going down to here, like I was saying, I'm using number holder 2 over here as well, and for I in number holder 2, I'm illuminating to that list. That will be returning the index and the value of that value in that of that index in that list. And if k equals I and not j equals number holder 2 dot index I, counter checker would be going up and up as this loop wants, because I'm going up and up because I don't want it to be looking at the stuff that's behind it, because I want to see if I didn't have this at all, and if I had a value before I would be I believe basically it would be the value in number holder 2, and if the index of I, if there's another value that's the same as I, and if I'm asking it for the index of I, it will be turning the one that's before it, right? So if the index of 0 is 1, and if the index at 4 is 1 as well, if I ask it to index 1 to find, if I put 1 in here, basically, it will be turning 0, because that's the first one that it finds, and that's what this counter checker would be guarding against, basically. And this would be if it passes this condition, it will be appended into the list over here, and then counter checker will be going up, basically, and this would be list of pair holders would be returned. And take notice that since I'm doing it again and again in the number holder, for I in number holder, basically, this would have multiple, especially if I have 4 of a kind in there, it would have won't be list of pair holders won't be 4, basically. That would be the length of it won't be 4, because it would be running for I in number holder 2, and it will be running again and again, and because there's more in front, there might be more in front, it will be running those again and again and again. So basically it will have more. So I'm gonna use the fact that this is gonna be larger than the actual value that I want, and I'm gonna implement that. It's actually very helpful because it helps me identify a lot of things, and I'll be using it in this logic all, which will be taking in a dictionary and then this dictionary will be attached to a value of a tail player, basically, and this would be it's actually like a combination of all these codes that I have up here, basically, and I have a scoreboard running. It will be going in a list, in order, straight and flush, straight, 4 of a kind, flush, full house, flush, 3 of a kind, 2 pairs, 1 pair, high card, basically. So then I'm running player in hand and dictionary items, and basically I'll be seeing if the pair ID would be 12, if a scoreboard if it's 4 of a kind, basically. And that's what I'm saying, what I'm doing over here, basically. And if it's a 12, this would be returned, basically, is the value, and I will be implementing it in over here. And then I have placeholder, number holder, and number holder 2 got them out of the list important. And then straight string will be logic of strings of hand, and list of pairs will be logic of pairs hand. And is it a flush? Logic flush of hand, basically. And rank would equal string strength. This would be basically how strong the value is, basically. And just comparing in the straight, if it's a straight, how strong of a straight it is. So if not, straight strength equals 0. If this is not equal to 0, basically it's not a flush. It's not a straight, basically. And if it's a flush, scoreboard of straight and flush will be going up. Basically, since this is not, this would mean that the straight strength is not 0, so is a straight, basically. If a straight strength equals to 0, it won't be a straight, basically. And that's what I'm doing in this, I believe, in this else function over here. So basically, if it's a flush, it will be going up, and straight and flush will be going up. This will be the category where royal flush will go in, and else scoreboard straight of player will equal rank, basically. Of the player, of course. Player would equal rank. Rank would be the straight strength value, and that's what I'm doing over here. And then else it's a flush, right? If else it's not a straight. It's not a straight at all. So I'm checking if it's a flush, and if it's a flush, scoreboard the flush of player will go up, and this would be sum list map eval of number holder 2. And I'm doing this because to avoid a for loop, basically. And what I'm basically doing is this map function, what it does basically is runs this function for each value in number holder, basically. And when it does that, after it does that, I'm making a list out of that, basically. Since this won't be giving me a list, it would just be giving me a map type value, and I will be making a list out of it, and then I'll be summing that list, basically. And then basically I'm doing the same thing over here, but this would be if it's not a flush, it has to be the value would probably be, it's not a flush, it's not a straight. So over here I want the high card to go up, basically. That's how the logic's working, and the scoreboard of high card will be going up, basically. And then next I have for keys in pair ID, if keys equals length of list number of pairs, which would equal 12, 8, 6, 4, 2, value would equal pair ID keys, and which would be scoreboard of 4, and value of player, basically, of one of these, this of a player, would equal, basically I'm doing the same thing over here, will equal the strength of it, basically. So how I'm doing this is, for a player, I would have in one of these scoreboards, I will have a player attached to the strength of their hand, basically. That's what I'm basically doing. And I will be returning all these in order. And take notice that I'm returning it in order, so that I have straight flush, and then 4 of a kind, and full house, and flush, straight. And this is how it's graded, basically. And I'll be using the fact that it's ordered this way, and logical comparer which will be taking dictionaries, and this dictionaries would be all these, basically. And for dictionaries, I'm trying to find a winner, right? So B equals to 0. So the one in one category, especially in the first category, whoever has the highest strength, highest rank would be the one winning, right? So that's what I'm implementing over here, basically. So for key strength in dictionary items, if strength is greater than B equals strength, and then after running this loop, I will check which values have that key, and if dictionary of key equals B, winner finder dot append key. Basically, that's what I'm doing in here. Now, if not length of winner find equals 0, then what I'm doing basically over here is for key strength and dictionary 8 of items. Dictionary 8 of items would be scoreboard high card, and I'll be checking that directly, because if we have a winner in that, if we have more than 2 winners in one category, we gotta find if that winner is it has the highest card, basically. So if strength of greater than B and key in winner finder, B equals strength, and then I'm running this again, I'm checking it again, and for key in dictionary of 8, if dictionary of 8 equals B and key in winner finder, and the key would be in winner finder, because winner finder will not be 0, true winner finder would append that key. So true winner finder is actually holding the actual winners, and if len of true finders equals to 0, that means there's when I was running this, I probably had more than basically I didn't have to run this at all, basically. Then winner finder would be returned. Else true winner finder would be returned, basically. Now, going to the next function, basically, the next program is skeleton. Skeleton would be using core and logic, both of them, and it would be the first function would be bet composer, which basically I want to go through this fast because I'm taking too much time. But basically, what it does is it checks if the bet is correct or not, because I have to find if the player is betting less than. It's basically an application of the bet of the betting function I talked about before, and what this would be basically doing is checking if the bet is actually 2 times is greater than 2 times the bet that they have to be putting in, or if it's equal to that bet that they're putting in. Because if it's not, it will be doing it again, which is which happen when true again is true, try again is true, and this while loop is run again. And if they match this category, the bet list will be removed, and will remove the bet that it has in there, because this would be having the bet list would be only having match bet, and match bet will be the bet that they have to match, basically, and that match bet will be moved, basically, and then the player's bet will be inserted, basically, and this would be one again. This would be try again would be false if this is true, if this runs, and if it doesn't run, it will be try again will be false. And over here is basically trying to find if it matches or not, basically, if it's a valid bet or not, and basically this is what it's doing over here as well. And basically this is an extension of the one that I was talking about, like I just said. And if the player folded, it would say the player folded, and it would be returning all this stuff. And bet matcher is the most complicated algorithm that I had to make, and this I'll not take time to go in depth into it. But what it basically does, if it checks if the player's bet is equal to the required bet. Required bet would be the one that would be assigned to using the blind bet, which would be the big blind. And if it matches that, it will continue to the next player, and the next player to match that. And if the player bets 2 times or more, that will be the new bet that the next player has to match. And if a player goes all in, he's ignored for the next bet matcher loops. And if the player folds, he's also ignored, and he will be deleted, basically, from the pocket, from the pot. from everything basically, because we don't want him to be in that bet matcher again at all. And the deletion doesn't happen here. It happens in Pocket Incinerator. Not really. It happens in I believe it happens somewhere else. But I make sure that the player doesn't get it. If a player folds, he's not asked to bet again, and his pocket will be the pocket that he had before he folded in, basically. I think it's in here. Yeah, since pocket will equal current pocket, if a player folds, he will not be his pocket won't be updated at all, and he will be deleted out of. Of course, you'll be deleted out of order list which would be the one that I'm using to run this while loop, this for loop over here, and he would be deleted out of that one, and better player would be the bet that the player had will be deleted as well, because we don't care about him anymore. And that happens if the player folded and the player went all in. The next one will be trying to find the blind, which player will be the blind, which should be the big blind or small blind. And how I'm doing this basically is I'm getting a blind giver. Blind giver will be going up and up, and not over here, but it's another function. This is actually just like I said, it's a skeleton for the next function I'll be talking about, which is in another file. And basically, this will be finding which one is the big blind and small blind, and blind giver will be going up and up. And the fact that blind giver goes up and up will be determining, as you can see, big blind and small blind, because I have them in there. And over here, I'm checking the type is the same as a numbers. If it's not, if it is the same as a number, then list of players would be list range from 0 to whatever number that this to the length of the list of players minus 1, basically. So that's what I'm doing over here, basically. And if this is equal to a number, I'm making a new list. If it's not, the list that this will give me a list, basically. So I'll be doing this, and it lets me be lazy, like I said over here. It lets me be lazy, and this will be implemented in the next code as well. A card dealer deals cards, basically, and it's using the functions I was talking about in the beginning. It'll be using all 3 of them, and it'll be repeating. I'll be repeating one other 2 times in this because current round will be putting in stuff in there, and it will be doing this. And then pocket determiner would determine what the pocket is, basically, and have a algorithm running over here. It will be dividing len of winner. Len of winner might be bigger than 1. So there's a few things that I'm doing over here to implement that every player gets what they deserve. And if a player folded, he will not be getting any more than he actually deserves. And this is actually this is implemented over here as well. And I'm using take notes. I'm using integer division because I don't want to play around with decimals. I don't want to return decimals. It would be annoying to return decimals because I have to round them. I could, but it just would be looking disgusting. So this is how I did it. And pocket incinerator, I delete the pocket if the player pocket is 0, I delete it, and this will be implemented in the code as well. And over here, I have a giant code. Basically, this would be looking at the little combinations that I can have of hand, and there's 21 of them, hands and the player hands and the community hand, and whichever one is the biggest will be the hand that will be returned. And finally, the winner determiner basically will be running logic compare and logic all, which I explained before, running those and doing that. And absolute decision will be deciding which one is the winner. And this would be one if len of orders player equals to 0 and len of dictionary players equals 1. This is absolute decision happens when there's only one player left, basically. If one player is left, that player is the winner. Basically, that's the code. That's the idea behind absolute decision. Now the next one is Texas Hold'em, the actual game, and I'm creating a dictionary, out of the first one is the dictionary creator, and I'll be creating a dictionary in this using one initial pocket. You put in initial pocket, and this will be used over here. I put 1,000, and I'll be running that, as you can see over here, dictionary creator. I'll be doing this over here, and going to the next function. Basically, what I'm doing over here is creating the game, basically. And there was a bug that I had, and I cleaned it up. But over here, what I'm basically doing is I'm playing around each round, and when I'm playing around with each round, if there are certain things that could happen, it's either that absolute decision, the function I talked about a few seconds ago. If that could be true, that would be one, and it would be returned. It would be break. It would be working. I would be returning it, and if there's only one player that's in the order pairs is the one that would be running, like I just said, in the bet. I believe it's called bet matcher. And if there's only one player in there, in order players, and dictionary of all in players is not 0. If it's 0, absolute decision will happen. But if it's not 0, then what we would do is nobody would be betting, because everybody would be just waiting for the community hand, basically. And so that's why I'm having this, and I'm breaking it, and it will be comparing it over here as well, and stuff will be happening down here, of course. And that's what I'm basically doing. And Tetris Hold'em real game, this could be changed as many times as I want. I could make new games by just changing this. I was actually coming up with a plan to make a game that goes n amount of rounds. I could do that. I actually made the code for it, but I didn't put it in here. But basically, what this one is actually just like the actual game in Tetris Hold'em. If a player pocket is 0, he's out, basically. And then that pocket incinerator that I just talked about, that's where it comes in here. Pocket incinerator once. If pocket is 0, he's out. You know what it is. Pocket incinerator 0. Pocket 0, he out. And it's actually done, I believe, around. Yes, it's actually done in here. Pocket incinerator is done. Pocket is deleted, and this would be checking. What this would be doing is if the length of pockets is 1, do again is false. Do again would be here, the while loop that runs this while loop, and the do again is false. This while loop stops, and for player and pockets, this would be print, and the winner is player forever. Player 1 or 2. I'm usually player 1, so I want to say player 1. So that's what it's basically doing. So I'll run this, and we'll see what's gonna happen. I'll run it up. Let's run it. Take some time. Over here I have the controls, what I'm supposed to do, but I already know it, so let's try it out. So I'm running this with 2 players, as you can see. I actually three players, and everybody gets an initial of $1,000. And if every player who's not player 1 look away and press enter, buddy. I want to mention if this one was not just if I put in dictionary instead of this, I could actually run the game. Basically, I'll have to change a few things. But what this does is it gives everybody the same amount of money when it starts. You can make different kind of games out of this. What I just needed was all this to be in there so that I could do it. So let's run this. So this is my starting hand. Remember this. I record it, and then this one's, and then player that. So now I can bet how much I want. I press B to bet. I press F to fold. Press B to bet again. And now these 2 players, I'm given how many I have to bet. See, but you know me, I like to bet all. I bet all. And player 3 is gonna bet all as well. Let's see who's gonna win. Bet and 7-7-0. So both of these guys are going all in, and it's run. Now final round, player 3 won, right? So now some player 3 won, and player 2 went all in, and player 3 won, and because player 3 had the better hand, the loop is done away. And take notice that you can actually find, sometimes you might actually find the same kind of numbers, same kind of hand in the same list, and that's because remember that I'm not controlling that at all, and this actually makes a fun of a game because I actually find it more fun when it's like this. That's why I did it. Now, just who's out now? Player. Someone should be out. Yeah, someone is out. So basically, that's how this game will be going. And thank you for watching this video. Until next time, see ya.